I thought it would be easier for me to do the lesson this way today because there's a lot of writing, so it's easier for me to type than write on the smartboard. So today we're learning section 1.5, constructing algebraic expressions. So an algebraic expression we already know is a math sentence made up of operations, numbers, plain constant numbers, variables, and so on. And in algebraic expressions, there's no equal sign, but if we have some that have all numbers, we can simplify them if possible. So in example 1, we're translating verbal phrases. Verbal phrases are like word phrases. So they're like fragments, like actual sentences in math. You might see some numbers, you might see variables, but you'll see words. And we're basically converting these into algebraic expressions, which have plus signs, minus signs, multiplication, variables, and numbers. So in letter A, 12 more than a number n. Well, 12 more than, we would have to know more than means addition. So we would either have here 12 plus n, or depending on the situation, because the commutative property of addition says you can switch it, n plus 12 would also work as well. Okay, the next one. The sum of 12 and twice a number n. So let me insert another text box. So the sum of 12 and twice a number n. Okay, so sum means addition. So I know if I'm having the sum of 12, it's going to be 12 plus, and twice a number n is multiplication. So twice the number would be 2 times the number n. Okay, that's how I would do that one. All right, the next one. The product of a number y and 10 is decreased by 35. All right, so first we have to understand the product is multiplication. So the product of y and 10. So to do this, I could use y times 10 like that with multiplication in parentheses. I could use a floating multiplication symbol. I could just do 10y. If I flipped it around, I just read it as y and 10, but you could totally do 10y as well. And this is decreased by 35, which is subtraction. So here's one way to write it, or if you wanted to just switch the 10 and the y and not have to include any multiplication symbol, it'd be 10y minus 35. All right, and then the difference of x and 7 all divided by 9. So let's see if I can do this with typing. So the difference of x and 7. So difference means subtract, x minus 7. And this is all divided by 9. So when I'm taking this, this all has to be divided by 9. So let me think. So I'm going to create a fraction bar. And to do that, I'm just going to underline this. There we go. That would be x minus 7 all divided by 9 like that. All right, in example 2, we are translating these expressions into verbal phrases. So this is why I wanted to use my laptop and just type, because there's going to be a lot of words here for this. All right, so 5 minus x. There's a lot of ways to type that out. I could just literally put 5 minus x. Now that's not the fancy mathematical way to do it. I like to use the word difference for subtraction. So I'm going to say the difference of 5 and x. It's important to write these numbers in the correct order. The first number has to be the first number you write when you are using subtraction. So 5 has to be first and x has to be second. All right, the next one, we can use the difference again. So the difference of 2, and it's not just a plain number for the next one. So it's not just x. So it's the difference of 2 and the product of 3 and x. Okay, so these start to get a little bit confusing because there's a lot going on here. All right, the next one, we have multiplication 4 times something, and what's being multiplied is the quantity of x and 6. So let's say the product of 4 and the quantity of the sum of x and 6. So that's a lot. But the product of 4, so it's 4 times the quantity of the sum, x and 6. All right. And then the next one, we could say, let's do, this is x plus 10 all divided by 3. Let's say the sum of x and 10 all divided by 3. That one would work for that. All right, so if we flip this over to the next page, we have some more examples, but these examples are using real-world situations. So in these examples, we're creating the we're creating the algebraic expressions from the word phrases. So the amount of money represented by X nickels in dollars. Okay, so a nickel is 5 cents, but in dollars, a nickel represents 0.05, like that. So if we wanted to know how much money we had in nickels, we would take 0.05 and multiply it by how many nickels we have, which represents X in this case. So that would be 0.05X. The amount of money represented by X nickels in cents. So this is similar, but now instead of having the answer in dollars, it's just going to be 5 cents and multiplied by X again. So a person is riding a bicycle at a constant rate of 12 miles per hour. Write an algebraic expression showing how far the person can ride in t hours. Well, if they're traveling at 12 miles per hour, and let's say they are riding for 2 hours, we do 12 times 2 to get 24. So to make an algebraic expression for this, it would be 12 times how many hours they are riding, which is represented by t. Okay, the next one. The distance traveled in 5 hours at an average speed of r miles per hour. So, again, this is very similar to this one in that we are traveling for 5 hours at the average speed of r miles per hour. So we would just multiply 5 times r. The next one. A person adds K liters of fluid containing 55% antifreeze to a car radiator. Write an algebraic expression that indicates how much antifreeze was added. All right, so we have a number of liters, which is K, and 55% of that is going to be antifreeze. All right, well, whenever we have percents, we have to change these to decimals. So we move the decimal point from where it's at to the left. Right now it's in between the 5 and the percent sign right here. So in decimal form, it would be 0.55. And we would multiply that by K to show how much fluid was antifreeze. A person's annual salary is Y dollars. Write an expression for the person's monthly salary. All right, so if in a year they are making Y, to figure out how much they make per month, we would divide by 12. So this would be Y divided by 12. Okay, and then the last one is kind of interesting, the sum of 3 consecutive integers. An example of that would be 2, 3, and 4. These are consecutive integers. So if the first integer is n, and we want to find the sum of them, that means add the 3 together, like 2 plus 3 plus 4. If the first number is n, we would have to add the first number by the next number. And to get to the next number, we take the first number and we add 1 to it. So the first number is n. The second number would be n plus 1. Like if the first number was 2, to get to 3, you would take 1 and add it to 2. So 3 technically is 2 plus 1. And then to get the next number, we would take the original number, like 2, and we would add 2 to it, since the next number after it would be 2 away from it. So the consecutive integers would be n plus 1 plus n plus 2. Now we don't necessarily need these parentheses. So we could just get rid of the parentheses, n plus 1 plus n plus 2. And we can simplify that. And we have 1, 2, 3n. So we can write that as 3n plus 1 plus 2 is 3. So that simplifies to 3n plus 3. If you flip this over to the next page, there's 5 problems that I want you guys to try on your own. And then we'll go over these together as a group.